Hello, welcome everyone. My name is Heike and I will be the host for yet another virtual Ninja Show episode. Today we are going to talk about advanced hunting and how you can visualize the data. And I have Kijo with me. Kijo, welcome on the show.
Hi, Heike. Thank you for inviting me today. My name is Kijo Girardi. I'm working in a FastTrack center in Japan. Every day, I'm mostly helping customer to deploy a Microsoft Certified Defender Suite. Today, I'm so happy to share a number of the insight regarding the KQL and then advanced hunting.
Yes, and you know, Kijo, I actually found you on Twitter and I was so impressed by all the goodness that you create and share. And that's why I reached out and asked if you want to join me for an episode. So you're doing a lot of things on GitHub, sharing examples, and I think you didn't just wake up and knew how everything works. So I would appreciate if you could also tell us a little bit on how you got started with advanced hunting and tell the audience maybe how they can get started.
Okay, so the reason why I started GitHub, especially focusing on the KQL, is I wanted to help everyone because KQL is quite new for the people who don't know about the Microsoft world, especially how to use the data. Even when I look at my background, I have no idea how to the writing programming, or I have no idea the KQL. That's why throughout my learning history, that would be a good idea to share what I learned and then out of the box query for everyone. That's the reason why I started.
Wonderful. So how would you let people start? Like, how would you introduce KQL and how would you suggest someone to get started?
First, I would recommend looking at the webinar done by Michael Melon. Personally, I learned the KQL from the syntax, like really basic grammar, because if you don't know the grammar, you have no idea. So you don't need to look at the really complicated query. You don't need to understand. Just go through the basic query. And after you learn the basic, you need to think about what kind of data you want or what kind of the activity you want to hunt. So after you learn the basic, everything followed by what you want to take it. So again, my suggestion is first look at the webinar or start learning the syntax. That's the first step.
Okay. So Kijo, I know when we talked about the episode here, you mentioned, of course, a couple of things that you would like us to walk us through. So how people can leverage KQL. And then, of course, it has a lot of tables. And you can create custom detection rules. And then you also later want to share a lot of examples where people can go to learn more. So maybe let's start with leveraging KQL, of course, in advanced hunting and how it works and how you assemble your query, basically.
So let's start from the KQL. So first, KQL stands for Crystal Query Language. It's a really powerful language for the threat hunting. Mostly, we use the KQL in a Microsoft Certified Defender, Microsoft Sentinel, or even Azure Data Explorer. So let me explain one of the example, because KQL is quite challenging, quite new for the people they don't know. I prepared this example. This query is mostly for taking the antivirus detections. So as you can see here, device event. This is a table which includes a number of the information regarding the device general events, such as the hash value or device ID, device name, or even process, etc. So we just define a device event in the beginning, but we want to take the antivirus detection activities. That's why we use the where. Where is mostly using for the filtering the activities. After that, action type equal antivirus detection. Then we can filter the antivirus detection data, but we want to summarize the detection based on the device name, because let's say device A might have the 40 cases, or maybe device B might have the 20 cases. That's why we use a summarize operator and count the activity based on device name. And maybe in this case, return the 5 record, but we want to take the only 3 record, then we can limit and 3, and then it's only return the 3 record in the end. So the KQL is quite simple and easier to write. It shows the more flexibility for the admin or SOC operators.
Wow. Okay. And of course, we also have the guided hunting now, where people can pick drop downs and create the query that way. Okay. And then, so how do you know? I guess you need to learn, right? So how do you know that you need to take device events? Because there is a lot of different schemas, and then in those schemas, there is a lot of tables. So is that just learning? Is that going through a documentation? So how did you get started with, like, where do I find what?
When we look at the tables, there are many tables and the schema data available. So let me explain one by one. So in advanced hunting, there are a number of the tables available. For example, alert and behaviors. When you look at the tables, like mostly alert related table, or even the Defender for Cloud Apps tables, but mostly for the alert related tables. When you look at the other tables, for example, apps and identities, this is coming from the Microsoft Entra and also Defender for Cloud Apps available. And also, if you are using the email, like Exchange Online Protection and Microsoft Defender for Office 365, you can also get the data and the table related to the email event. And also, more importantly, if you're using Defender for Endpoint, you can get the table generally about the device tables. Also, you can get the vulnerability tables related. So in total, 41 tables are available. So normally you can use the each tables individually to hunt some suspicious activity, or even you can use the multiple table to combine to get the more specific data by using the, for example, join operator and then mix with some schema.
Okay, so the more Defender products you basically have, of course, then more tables show up. And then you can use these advanced hunting queries, which I always loved, to create custom detections. Basically, something that runs on a regular basis and then will alert you, or you can configure to block it, to delete it, or to isolate a device, or whatever action you want to take. You want to explain a little bit?
Custom detection rule is literally, it's a detection rule. It's a really powerful feature because if you write the query is looking at the activities in a Microsoft Certified Defender. Once the activity detect or match with the activity, these custom detection rules generate alert, even take the response action to the each asset like email, identity, account, the device, etc. So means like automatically take action to the device. In this case, it is possible if something suspicious activity happen, if you create the role, it's automatically isolate the device from the network. Even you can run the antivirus scanning. It's really useful and powerful. By using this detection rule, it helped the SOC people to reduce the work. Also, everything automate their daily life task. Also, as a frequency, it's constantly working as a near real time NRT, or even 1 hour or 3 hours, 12 hours, and even 24 hours available.
Yes, I remember we did an episode with Christos when the near real time detections were just published. Okay, so, and of course, we want to go deeper now and have a look at advanced hunting queries and look at the visualization. But what are some of the resources that you could share with the audience that helped you to also get started?
Okay, first, there are a number of the communities which you can leverage in order to learn, even use the KQO. First, for the beginner, even like me, I have no idea what the query is for. I watched the webinars. Michael Malone covered amazing webinar from the episode 1 to episode 4. He covered from the basic syntax to the advanced syntax. I learned everything one by one. After I finished this course, I could write a query without any problem. First, you need to know the syntax. After that, you need to think about what kind of data activity you want to take it. Based on that, you can write a query. So I would say the first watching the webcast by Michael Melon, I highly recommend it. But also for the intermediate, more expert people, you guys can look at it, Microsoft Threat Security blog, because always Mystic is tracking the nation-based attack or suspicious attack, and they also wrote a blog. But at the same time, they also cover the queries. So you can definitely use these query to hunt the suspicious activity, or even the Microsoft Sentinel GitHub page. They officially provide number of the out of the box queries, so you can definitely leverage it.
Perfect. Thank you. We will put all those links in our description for this episode. Good. So now let's get started, Kijo. What's our first query?
Okay, so the first query is about attack surface reduction rules. So let me explain what attack surface reduction rules are. First, attack surface reduction rule, a prevention capability aimed at reducing the potential attack surface of the OS by, for example, blocking macro or scripting file, WMI, and more. This is highly effective for hardening the device security. So as a first query, we'll generate a pie chart displaying the overall distribution of ASL rule block detection. Similarly, for auditing detection, you can also generate a pie chart from the second query. Okay, so let's run the first query. After you run the query, you'll be able to see that the great pie chart. By using operator, when you look at the code 8, there's a render pie chart. The render is an operator to generate the visualization. At this time, we would like to see the pie chart. That's why we use the render after write pie chart. So this pie chart is really useful because you'll be able to see that how many cases are detected for each individual ASL roles, and it also show you the percentage. So that's why when you would like to see that high level overview, it's really helpful as an organization, what kind of the ASL roles are detected, also the percentage and the cases.
Wow. And then could you potentially also then click on one of the piece of the pie and go deeper and understand more?
In the pie chart, when you click the each tables, I would say it shows the cases, plus also you can see that percentage each individual ASL role's name.
Oh, wonderful. This is so cool. I didn't know you can actually already do this in your query. So you say render as a pie chart. Wonderful.
Yes. Actually, let me also explain about the technical perspective. First, we use the device event because device event include a number of the schema about device information. And after we want to track the 7 days activity, that's why we use the timestamp ago 7D. And also you might be noticed that each ASL roles start from the ASL untrusted, ASL scrapped, ASL PEXEC. It's everything that ASL. That's why in order to seamlessly take the data as ASL rules, we just define the start with ASL. That's the key why we have to use the start with ASL.
Okay, wonderful.
Also, let me talk about more detail. You can just use this query itself. It return the record, as you can see. But when you look at here, just the returning data mixed with the blocking and auditing. In order to identify between auditing and blocking, we need to use the post.json. So here there's a additional field. Additional field is mostly using for more detailed data. And when you look at here, is audit false means like it's a blocking activity, but we need to filter this activity to take the only blocking activity. That's why we use parse.json. The parse.json is mostly using for taking dynamic value because dynamic value is complicated. That's why we use the parse.json take the dynamic value. This dynamic value goes to the variable path. And after we define path is audit equal false, and then only take the blocking activities. And after that, we count these ASL roles based on the action type. And like Heike, you mentioned, we use the render pie chart to show the pie chart in the end.
Nice. Yes. Beautiful.
Thank you. Vice versa, if you want to take the only auditing data, you have to just switch the line 15. Instead of the false, we just change to the true. Auditing equal true is only taking the auditing data. So output looks so similar with the first query, but the difference is only taking auditing activities. So this is about the first query of the ASL rows with pie chart.
Wonderful, beautiful. Thank you. Okay, so you just showed the pie chart. Is there any other visualization that people might be able to create?
Yes, I can show you the one more demo about data visualization in the ASL rows. Previously, we look at the pie chart, but also by using a column chart, you can see that the detection based on the categories. Because ASL rows nearly exist 16 rows, but it's quite hard to track the 16 rows. So maybe some people want to look at the office related detection or email related detection, or it could be a scripting related detection. By using the next query, you will be able to see day to day what's kind of the categorized activity detected, also detection cases.
Let's do it.
So this query provide a daily categorization for the ASL rows. For example, there are currently 16 rows in the ASL row. For example, SOC analyst might want to track the day-to-day detection rate of the specific categories, such as office related or WMI related. So this is the best way to visualize it. So when you run the query, you'll be able to see the amazing graph based on the every single day. When you put the cursor, you'll be able to see that what kind of category was detected. Also, you can see the detection cases. So when you look at here, it shows the number and also categorization. And then you can see that whole 1 week, what happened. Or sometimes, obviously, you can see, oh, 30th October, maybe the office related application of office related activity highly detected. So you can see the right away what's going on for the visualization.
Yeah, this is nice because you can see it over time and you can see if you have spikes or if it goes down because you have a better protection against it.
Also, so let me talk about the technical aspect. Code 20 to the 25, it's quite similar with the first query, which we show the pie chart. But the only difference is after code 25, it's about summarization. So how we leverage this summarization. Because we want to categorize based on each activity. For example, when you look at the email we want to categorize. So that's why we use the count if, not just count. We use the if as a condition. So we are going to count activity if action type in ASL executable email contents block or ASL office communication app child process blocked. So one of the action type must be in there, and after it's counted as a detection case. So I divided 16 different rows.
And are these the only two existing for email, or how do you know how many of these conditions needs like are available?
Oh yes, it's technically this condition is available. You can just define what you want to take the action type. So if you want to take one more additional action type, you can just add an action type. But the reason why I categorize email script WMI is based on the Microsoft Great documentation because they categorize the email related script related. So just while there are 16 ASL rules, I just categorize based on the each activities. So again, if you want to just add one more additional the action type, you can just add the action type after the, let's say, code 26 ASO office communication app child process block, comma, and add one more action type.
Okay, and the action types, you can find all of this in documentation. That's
Exactly.
yeah. Okay, nice.
And again, we use the render in order to show the visualization. At this time, we use the column chart instead of the pie chart.
Nice, nice. Okay, what additional demo do you have to make me even more surprised here with all the beautiful data?
So next demo is web protection. So web protection mainly consists of the web content filtering and custom indicator in Microsoft Defender for Endpoint. Web content filtering blocks a website based on the categories such as gaming, gambling, um, etc. Even sometimes SNS. So there are many categories, so you can check about it. By contrast, indicators are used for blocking or allowing the specific website or URL or even IP address, mostly using for indicator of compromised IOC. Let me explain the logic for the detection. This is not about advanced hunting. In a web content filtering and indicator, if the detection are coming from the Edge browser, the smart screen primarily serves as the engine. But for third-party browser, such as the Chrome, Firefox, Opera, even other browser, if the user you access one of the URL from the other browser, network protection is working as an engine. The reason why I'm talking about this logic, because this is quite important to capture the activity, because when we use the data as an action type, we take the, for example, smart screen in order to take the edge related detection. If we want to take the third party related, we have to define as a network protection in action type.
Yeah, that makes sense. So I always considered it is smart screen in the box. So basically, everything that is not from Edge, but from the box, any app that tries to connect to any suspicious, malicious destinations, network protection comes in. So, Kijo, before you jump in, can you explain the query a little bit for us? So, what is it about?
So this query will help the listing the URL detected by indicator, web content filtering, and the smart screen based on the device, along with the user accessed URL from the Edge browser. So the all detection is coming from the Edge. So user might access the URL from the Edge browser, but we don't really know. That's why to figure it out, we use this query.
So you have first the device events, action type smart screen URL warning. Later you have MDE WCF, make list, edge, smart screen. What did you write there?
Exactly. This is really complicated. So let me run the first query and it will generate the output. And also let me talk about the technical perspective. So the first one, after you run this query, it will return the record. When you click the one record, let's say Win10B as example, you'll be able to see that how many cases are detected, Defender for endpoint, indicator, 4 cases, web content filtering, 9 cases, smart screen, 8 cases. And also when you look at each value, you'll be able to see that it's listing the or detected URL. So that's why when you look at the indicator of compromise, for example, bbc.com or cnn.com or even JTU or JP or these URL are detected as an indicator. Also, continuously, when you look at each web content filtering, a smart screen, it show you the detected the URL and plus time. Even you can look at these result in a report capability, or even you look at the incident. By using this query, it shows more flexibility because you can see that the total cases, each category cases, even you look at the time and the URL. So that's why it's a really useful to use this query.
Okay, now you're turning this query into something looking good at the results, I mean.
Yes. Also, let me talk about the technical perspective, like what exactly we are doing is, because I understand it's really complicated. So as a first point, we use the continuously again device event tables, but we just changed the action type. Previously, we are looking at the tracking the ASL activity, but this time we are looking at the web protection and also Edge browser specifically. That's why, like I said, as a smart screen is working as an engine, that's why we define the smart screen URL warning. So this is the first important point. Additionally, we used again post-JSON additional field because it's same as a attack surface reduction rule. There is a value to differentiate between indicator, smart screen, and web content filtering in additional field. As you can see here, there's a experience custom block list. Custom block list stand for indicator detection. At the same time, custom policy indicate web content filtering. And also smart screen is mostly written like malicious or untrusted phishing. So that's why we define these data to filter well. And then after, if something happened, we are listing these activity. How we can list each value? We use the make list. Make list is working to gather the dynamic value. So that's why when you look at the demo under the defender for endpoint IOC indicator, it's listing the each detection. After make list if date time, as you can see here, and plus the remote URL, it's taking the URL which user access, and in the end, it's detected as an indicator. And also the last one, code 8 to 10, I used the array length. This is a counting dynamic value. The reason why we use it because we want to see that how many cases are detected in each IOC or web content filtering smart screen. Array length is counting dynamic value, means after listing each value, for example, in this case, MDE under IOC, this dynamic value is counting. In the end, it's returned as a total number. That's why we can see that Defender for Endpoint IOC detected 4 cases, Web Content Filtering 9 cases, Smart Screen 8 cases.
Nice. So, Kijo, what made you write this query? So, why is it so important for SOC analysts to see the data in that way?
Yes, actually, this is a common question from the number of the people. We can use the report capability in a Microsoft Certified Defender. Even we can track the alert and incident, but to track the these activity is quite hard and time consuming because every day it's happening these activity. That's why in order to make a list and then see and understand right away, this query will help you to visualize everything. This is not really visualization like ASR rules, but when you look at these record, oh, Windows 10B, how many cases detected for each indicator with content filtering, smart screen, and also you can check the time and access the URL. That's why these queries are helpful and insightful for the people, especially tracking these activity, especially the SOC analysts.
Okay, thank you so much, Kijo. And I think you brought us one last demo for our audience. Wow, this is another complex query here. So what are we doing?
So this query will help you to understand the URL accessed by end user detected by Defender for Endpoint indicator URL and web content filtering, but also reveal the type of the browser launched by end user. So furthermore, by combining the network data table with URL, the query provide insight into the IP address and the port number. So let me run this query, and after it show you the record. When you look at the record, you can see that the number of the record, but when you look at each one by one, you can see the time, device name, even the detection type. Detection type is a third-party IOC URL, means oh, this is not Edge browser. It could be Chrome or Opera, Firefox, and maybe detected like that, and also indicator of compromise. Even we can figure it out the third party browser next to the detection type. As you can see, detection type, third party IOC URL, and next initial process file name. It is written the Chrome exe, means obviously we can understand, oh, this device access to the suspicious URL from the third party, but at this time, the Chrome browser. And also you can see that IP address and the port number. If you just take the data from the device event, you won't be able to see that the IP address and port. But by combining the network event you can see that these IP address and the port, it's like combining the multiple different tables.
Mm-hmm. Nice.
Lastly, let me talk about the technical perspective. So how it is working. It's quite similar with the previous tables. We just defined the action type smart screen warning, but at this time we want to track the third-party browser activity. That's why we added exploit guard network protection blocked. And after that, we used again a path.json to take the dynamic value. As a dynamic value, it's included to the value to differentiate indicator and web content filtering. And at this time, we used also case operator called 28. This is more differentiate again smart screen. And in this case, because it's a detected smart screen, that's why edge plus custom block means indicator. And also if it's detected again custom policy, it's take as a web content filtering. It's quite same as a smart screen URL warning. It's a network protection. Again, we are looking at action type and also look at the dynamic value. If dynamic value is a custom block list, it's a IOC. And if it is again custom policy, it's taking the web content filtering. In the end, these data combine with the remote URL, and after that, it returned the data with the URL and then IP address, and also the initial process and detection type. So this is how it works, this query.
Wonderful. Wow, thank you so much, Kijo. So I know many people probably, whilst we are talking here, asking us about where to find all of these queries. So I would assume you have them on your GitHub that we can share. Is that correct? You have them there?
Yes, all the query in my GitHub. So if you guys want to see the query and try it, please visit my GitHub account, and then always happy to share the GitHub. Also, if you have any question, I'm also happy to help you.
Thank you so much. Yes, we will share how people can find you. Okay, Kijo, thank you so much for walking us through. It started as a basic, and then you went crazy with the queries. I loved how you can actually super quick by adding pie chart and other visualization operators to just get something in a much easier way to understand the data. Thank you so much. And yeah, I know that you will continue to impress me with your GitHub, and I hope I can invite you maybe one day again back to the show. For now, thank you, and thanks everyone for watching.